Welcome back everyone to Data Science for Everyone. Today we're going to be talking about imbalanced classes and classification algorithms. Let's get started. Classes. So imbalanced classes themselves, okay, are, again, a lot of the times whenever we're doing like gradient boosted descent, we're doing any type of tree-based models, or anything like that, or anything that has the tendency to be clustered, okay, sometimes and a lot of times we're not going to get a great accuracy rating. So for example, if you have only one positive case and 99 negative cases, okay, of something, well, you're almost always going to have a 99% accuracy, okay, simply by just classifying everything as negative. So we need to deal with that, and that is how we deal with imbalanced classes. Now, usually, for example, we'll use something like accuracy, okay? That's the AUC that we've talked about in the past for calibrating models. Precision and recall are even better options whenever our target sizes are highly different. However, those are just some options, okay? Now, let's talk about maybe tree-based models, okay? They want to perform, and this is depending on the distribution of smaller class sizes, classes being some grouping. Now, if we tend to be clustered, okay, so they're really highly dense, then they can be classified easier, but if they're sparse, it is much more difficult to classify them. Now, ensemble methods, so that's like gradient boosted trees that we've looked at in the past, or these random forests, okay? Again, they will usually aid in pulling out the minority classes quite well. Bagging and boosting are going to be options as well. Again, that we've looked at with gradient boosted trees and whatnot. Now we also have penalized models. Okay, and so we can weight the classes, and this is using something like the balanced feature whenever we're talking about scikit-learn. But one of the best things to do is just do some basic statistics. So let's maybe let's do this. Let me actually get some data in here. And I'll just do the normal imports, and this is really small. Let me get that up there. Let's see, import matplot lib.py plot as plt, and I don't know if we'll use all of this. This one's gonna be a little bit more of a ad lib whenever I'm talking about the data. But let me grab a data set. What do I want? Let's do maybe the Titanic data set. So SNS dot load data set Titanic. So first off, let's actually take a look here. We have this survived class. Okay, so let's take and let's actually just do a little bit of statistics on it, okay? So if we take Titanic here and we do something like value counts, and I want this of survived, and let's actually do something like plot kind is equal to bar figure size is, let's say, something like 10 by 10. So you can see here clearly that these classes are imbalanced. Okay, and so let's actually look, and let's actually just take this here and actually just look at the counts itself. So you have survived here, 0 being not survived, 1 being survived. So 554 people died, and we have 342 people died. So how would we want to get this to be a balanced class? Okay, now there are a couple methods that we can use here. So we can do resampling methods. All right, so one of these is being upsampling, and another one of these is doing downsampling. Okay, so let's talk about this first method really quickly, okay? So the first method being upsampling, and let me do something like this. Upsampling. So when we do this, let's do from scikit-learn .utils. So we're grabbing one from the utilities, and we're going to import resample. Okay. Now we want to go through and let's create a mask in here and do something like Titanic survived is equal to 1. Okay, so this is anyone who survived. Now, if you remember what a mask is basically giving us a Boolean vector. And so then we can actually subset our data. So we can say survived data frame, and that's going to be this Titanic, and we'll call it with the mask. And there, again, you can do this all in one, but again, sometimes it's nice to be able to just keep the mask in there. Now we have a full sample of just our survived individuals. Now let's call this a death data frame here, and this is Titanic here, and then we can use the tilde to do a mask, and then we can grab here. And so let me actually grab, let me do the value counts on these so you can see them. So survived and survived here dot value counts. Whoops. Why? Oh, whoops. So here you can see here we just split out and we have only those that are of the survived in nature, and then the same thing will go here for the death one. And you can see here those that died is 549. So then we can actually do this, something like this is df, and we'll call this the upsample here, and we want to use the resample function that we grabbed from scikit-learn utilities, and we will use the survived data frame. We will replace is equal to true, and then we will also do something like in samples here, and we want this to be the length of the death data frame. Okay, and then we'll also create a random seed here, or random state, sorry, of 42, and then we can run this. Now, what happened here, okay, is we resampled. So let me actually do resample and then do survived dot value counts. Oh, and I shouldn't have done it that way, but it's fine. So here you can see we still have our full value counts. Okay. Now we need to also do this. Now notice that this is that we resampled. Okay, this survived data set with replacement. So for example, we basically put everything, all of the data sets and all of the observations in a bag, and then we wanted to resample the data to have the length of this death data set. And remember, the length of this death data set is going to be this 549, and we set this random state. So then we constantly pick out a random sampling of our survived data and we also replace them back into the bag. So then we're grabbing completely random observations out of there to get our current number. Now we can actually grab a full data set. So let's just call this Titanic 2 here, and then we can actually just concat the two together. PD dot concat here, and we want to grab the death data frame and the data frame upsample, and then now we can actually do df Titanic 2 dot survived, and then we'll do dot value counts. And if you notice here, we have now upsampled our data set so they are both equal sizes. Okay, and again, this is just using statistics, okay? This is a perfectly reasonable way to do this. Again, this is very similar to the way that we had a really large data set, billions of observations, and we just did a random sampling of the data, okay, to re-grab up the data. So this should have a relatively same composition that we had before. And if you look at the data now, so let's look at what else do we want to actually grab here. Let's do something else. We can do there's also another library, and I don't know if this is standard. Yep. The IMB learn. Okay, so this is actually for imbalanced learn library. Dot oversampling import, and here we want random oversampler. This is just a similar way to do that. Okay, and so let's create a random oversampler. And again, this is just another example. So for oversampling. And so we want the random oversampler, and let's set a random seed or random state here to 42. And then we want to do the same thing. So let's do x if we did it this, let's do it this way. So let's do x is equal to, and I'm going to do the basic Titanic data set, and I want to drop here, what do I want to drop? Survived, axis is equal to 1, and then here we're going to say y is going to be the Titanic data here, and we want survived. So then we can use this, we can say x ROS, is that's for our oversampling, a y ROS, and then we'll do ROS dot fit here, and then fit sample, sorry. Fit sample x, y. Uh-oh. All right, let me do dot drop NA. Dot drop NA. And why does it still want to do that? Because they're inconsistent numbers. We'll do it this way. Titanic 3 is equal to Titanic dot drop NA, and then this would be Titanic 3, and this should work on this one now. Yeah, okay, and we do have a future warning. Don't worry about that. Some of the things are going to be depreciated, but what we'll actually see here now is if we do something like pd.series, well, actually, what is y real quick? Y dot value counts. Okay, so here we actually see that y, not y, we want to, here's y for our value counts, okay, but we can do y ROS dot value counts. Oh, and I need this to be a series object. That's what I was thinking about. pd.series and run that. Now look here. Now both of the samples are the correct size. Okay, and this again, this is oversampling. And so you can see that we can do the same thing here with x dot well, it's not actually going to matter at the moment, because again, what we were wanting to look at here was the imbalanced classes. This one was imbalanced. Okay, well, this was imbalanced. This is imbalanced, and this one is balanced. So that was, again, that was still upsampling the minority. Okay, so that's we had these. We were going from small to large in that instance. Now, if we want, okay, we can also do something like downsampling here. Downsampling the majority. Okay, and so we have our resample utility. We have our, let me actually I want to rerun. Did we, nope, we're good. Okay, so we have our two data sets, okay, of our survived data frame and our death data frame. These are the two that we're going to be working with again, and we're still going to be using the resample function. So, but let's call this a new one df here, and it's a down sample. So we're going to resample, and then we want here, instead of our survived, we want our death data frame. And here, though, we do replace. Replace here is going to be false. False. Because again, we are just extracting from the larger sample. We don't need to have any resampling done in there. We don't need to be re-grabbing out, okay, to upsample. And then the next one here, we will do something like in samples here, and this is going to be the length of the survived data frame. And then we'll need to set up a random state as well. And we'll set that equal to 42. And then we can set up Titanic, and let's say that we want this to be Titanic 4. Okay, and so then we can do pd.concat, and we can do something like the survived data frame with our data frame of the down sample. And then again, we can take this Titanic 4.survived.value counts and take a look as well. And now here you see we have 342 and 342. And so a couple of other things that you can do is you can do something like doing something like an upsampling and then a downsampling, and there's a couple other different ways to do this, but I would suggest if you have these imbalanced classes, I would go on ahead and do just what we've done here today. Thank you guys for watching. If you like this, please comment and subscribe and share as much as possible. I look forward to any comments I see. All right, thanks. Bye.